In this video, we're going to be talking about what is cardiomyopathy. And to start, I'm going to just write cardiomyopathy in 3 parts. And the reason I do this is because if you break down cardiomyopathy into these 3 parts, you get an understanding of what the disease is. And so, because cardio stands for heart, myo stands for muscle, and pathy stands for pathology or disease. So you can get an idea that cardiomyopathy is a disease of the heart muscle. All right, now before we really dive into cardiomyopathy, let me just kind of go over, do a brief review of what the heart muscle exactly does. So I like to think of the heart as a series of 2 pumps that are separated by the lungs. So let's draw that in here. And this first pump I'm going to call the right heart. And the second pump I'm going to call the left heart. So the purpose of the right heart is to bring blood from the body and send it to the lungs. So let's see how that works. Well, think about this pump just kind of drawing up here, and it's going to bring in some blood. So let's see that happen. So now that the right heart has drawn blood into it from the body, it's now going to pump that blood to the lungs. Then once in the lungs, the blood is oxygenated, and then the left heart is used to pump the blood from the lungs to the body. And this is in a very similar manner as the right heart. So let's see that here. And what's cool about the heart is that these 2 pumps are actually pumping simultaneously. They're both going up and down and bringing blood from the body to the lungs and from the lungs to the body, and then this blood actually that's going to the body eventually circulates back to the right heart. It goes to all the different organs where oxygen and different nutrients and waste are exchanged before it goes back to the right heart, and it just circulates like this. And it's these 2 pumps that keep the blood moving through the body. So this is just kind of a very simplified diagram of how the heart works. Let's bring in a little bit more anatomical diagram of the heart to give you an idea of how these 2 pumps are kind of contained in one unit that is the heart. So here we have a diagram of the heart, and I want you to think of this heart as if you're looking at someone and this heart is inside of them. So it's kind of mirror image. So over here on the left we have the right heart, and then over here on the right we have the left heart. And what happens in the heart is that this muscle, the walls of the heart are a big muscle. And when these muscles relax, the chambers of the heart actually get bigger. So let's kind of see that. And this dilation of the chambers, just like in the pumps up here, it draws blood into the chambers. And this is where it comes into where I say it's kind of like 2 pumps, because it's at the same time it's drawing blood in the right heart from the body, and at the same time it's also drawing the blood into the left heart from the lungs. Now that the blood is into this chamber, into these 2 pumps, the heart muscle, this wall here, it contracts, and it makes that chamber a lot smaller. And that's this contraction force of the muscles that actually expels the blood in the heart chambers to either the lungs from the right heart or to the body from the left heart. So now that we have an idea of how the heart works as 2 separate muscles within one unit, pumping blood from the body to the lungs and from the lungs back to the body, I'm going to kind of erase my work here and show you how the heart muscle itself can become diseased and result in a cardiomyopathy. All right, so I'm going to just draw 3 more pumps here. So there's kind of 3 ways that the muscle of the heart can fail, and the first one is that you can have a power failure, or you can have a pump that's just too small, and lastly you can have a blockage. So in this first example, the pump is supposed to kind of go all the way up and down here. But imagine if this pump doesn't have quite enough power and it's not able to pump this full distance. Say it's only able to pump, maybe from like here to here. Just this very short distance. So every time this pump goes up and down, it's still working in the fact that in the sense that it's drawing blood in from the body or from the lungs, but it's just not drawing as much in with each pump, and therefore when it pumps out, it's also not pumping as much out. So this pump is not as efficient and it's failing. And so I'm going to just define failing here as kind of a decreased output of the pump. So if your pump's only going a little bit up and down, if you have a power failure, you're going to have a decreased output of the pump. And another problem you could have with your pump is that the chamber of this pump is too small. Now this pump, it has a smaller chamber in the side. So even if this pump is able to pump that full distance up and down, it's still not bringing as much volume, as much blood into the chamber and pumping it out. So in this case, you have this power failure where it's not going up and down as much. So the output of the pump is lower. In this case, it's going up and down all the way, but the chamber is smaller. So the volume of blood it brings in and out is also decreased. So maybe I'll write that in here. We have a decreased flow coming out of the pump. And over here, we also have a decreased flow coming out of the pump. All right, so how about this last mechanism? Well, let's just imagine there's a blockage here kind of in the outflow of this pump. And so now when this pump is going, even though it's going, the full distance up and down, like in this example, but the blood that's trying to come out of the pump, it's getting blocked. And so you're not getting as much flow out of the pump. So that once again here, we're going to have a decreased flow. And these are the three different mechanisms by which the heart muscle can fail to result in a cardiomyopathy. So let's see how that works with a few hearts. Now let me just draw these hearts in here. All right, so in this first example, I said we have a power failure. Well, what does that look like in cardiomyopathy terms, or what happens in the heart? Well, what happens when you have a power failure is actually the chambers of the heart dilate a lot. So let's draw that in here. They get really big. So when the chambers of the heart dilate like this, it actually stretches the muscle really thin of the heart wall, and that muscle that being stretched so thin, it's not as effective at pumping. It doesn't have as much power. So kind of like up here where it can kind of just go up and down just a little bit, but not the full pump. That's kind of what happens here, is that the heart muscle isn't able to fully pump. And so even though it's getting bigger, it's still kind of got this power failure. It's not pushing as much blood out of the two pumps. And this power failure and dilation of the heart chambers is known as dilated cardiomyopathy. And so dilated cardiomyopathy is kind of aptly named because the heart chambers become dilated, and it's that dilation that thins the muscles that causes it to have a decreased forward flow and a failure of the heart. All right, so now let's talk about the small pump here example. And how does this correlate to a cardiomyopathy? Well, in this case, the muscle walls of the heart chambers become really thick. So I'm going to just draw that in here. And when this happens, when these walls become kind of thick and scarred down, they're not able to expand. And that expansion or relaxation of these muscles is what draws blood into the chambers from the body or from the lungs. And so it's kind of like here where you have this smaller chamber. Now that it can't dilate out, the chamber effectively becomes smaller. So even though every time this muscle flexes and it pumps the blood out, it's pumping almost all of the blood that's contained in these ventricles or these chambers, but it's not able to bring enough in to actually have a normal flow out. And when this is known as restrictive cardiomyopathy. So now let's go to this last example here where we had a blockage of the outflow. And how does this relate to a cardiomyopathy? Well, in this example, there's also kind of this thickening of the heart muscle. However, in this case, this thickening of the muscle wall is actually asymmetric. And in this center portion here, known as the septum, it becomes really hypertrophied. It goes really big, and it actually blocks the outflow of blood through the aorta, which is sending blood from the left heart here to the body. And so you get this blockage, but you also do kind of have some of this small pump phenomenon. And this is known as hypertrophic cardiomyopathy. So to recap this real quick, just remember that if you break down the name, you can kind of remember that cardiomyopathy is a disease of the heart muscle. And this disease of the heart muscle results in a decreased outflow of blood from the heart. And it can kind of be caused by three different mechanisms. You can either have a pump failure, as you see in dilated cardiomyopathy. You can have a pump that's just too small, like as in restrictive cardiomyopathy. Or you can have this blockage of the outflow of the blood from the heart, as you see in hypertrophic cardiomyopathy.